Given a parametric equation R of t, the principal unit normal vector is defined as t prime of t divided by the norm of t prime. Here t is the unit tangent vector. Let us look at an example. Here R of t is given by t square I plus t of j. We have already calculated the unit tangent vector, which turns out to be 2t divided by square root of 4t square plus 1 I plus 1 divided by 4t square plus 1 square root j vector. Now, for the sake of convenience, we will write this as t1 of I plus t2 of j. Let us take the derivative of t1 with respect to small t. We can use the quotient rule of differentiation. Let us recall quotient rule is given by u by v. If you want to take derivative, it is given by vu prime minus uv prime divided by v square. So therefore, t1 prime is given by 2 4t square plus 1 square root minus 8t square multiplied by 4t square plus 1 to the power of half minus half. This whole thing is divided by 4t square plus 1. Now we can simplify t1 prime a bit further by multiplying and dividing it by square root of 4t square plus 1. Notice 4t square plus 1, if you multiply and divide, it is effectively as if you are multiplying t1 prime by 1. This kind of trick is very useful in mathematics, and the more problems you work out, the more experience you will get as to where this type of trick is applicable. So let us simplify t1 prime, and you should get t1 prime equal to 2 divided by 4t square plus 1 to the power of 3 by 2. Similarly, the derivative of t2 prime is minus 4t divided by 4t square plus 1 to the power 3 by 2. Thus, the derivative of the unit tangent vector is given by the following expression: 2 divided by 4t square plus 1 to the power 3 by 2i minus 4t divided by 4t square plus 1 to the power 3 by 2j. Now let us calculate the norm of t prime vector. The norm of t prime vector gives you 4 divided by 4t square plus 1 square under a square root sign. That is, you square this term, you square this term, and then add and take the square root. So you will get 2 divided by 4t square plus 1. Therefore, the unit normal vector now can be written as t prime of t divided by the norm of t prime, and you will get 1 divided by square root of 4t square plus 1 I vector minus 2t divided by square root of 4t square plus 1 j vector. Here I must mention that this unit normal vector is perpendicular to the unit tangent vector. Perpendicular to unit normal vector. And this can be easily checked by taking the dot product of n vector and the t vector. Since they are perpendicular to each other, if you take the dot product, you will get the answer as 0. This completes the lecture on unit normal vector.